we're going to shift the parabolas. We are no longer going to be bounded just directly at the origin. We're going to move some stuff around and have them floating into space. Which means we're going to introduce a horizontal and a vertical component to it. Which you, H and K, go figure. So H and K is going to come back into this one for our shift. This is vertical. Because C was already taken. C was already taken for the Pythagorean theorem. B is lost.
What about A? That is so, wait, never mind.
What?
J. You're seeing a lot of things.
J?
Yeah, you have H, I, J. Yeah, I just imagined what about H and J?
H is, usually height or horizontal, but a lot of times J is used for function notation, like f of x, it's j of x, g of x. They use that stuff for combination of function stuff, so they use the middle letters for that.
I got you. Like, why can't you use B? Why do we use Because that's the last
Volume.
Anyway, let's introduce the horizontal and vertical component to this. What happens here is we take the same basic ideas we did yesterday. Instead of having a y squared, it's now the quantity y minus k squared is 4p times the x minus h. Same idea, it's x minus h quantity squared equals 4p, and then y minus k. And what's nice about this, the h and k here now represents the vertex. H and k is going to be your vertex. Okay? Psst, take out your earphones. Thank you. H and K is always going to represent your vertex. Always, always, always. Now, what a lot of people tend to forget, forget on these things is that you're just pulling out the values here. Think about when you guys worked with point slope form. When you guys worked with point slope form, it was y minus y sub 1 m x minus x sub 1. Big, you remember that?
Yeah.
If you had an ordered pair of -2 and 3, you would rewrite it as y minus 3 is your slope, whatever it is. X. When I write minus and -2, I write it as +2. So you're always moving around with those values. It works the same with these with your H's and K's. Works the same. All right? So what I want to do today is I'm going to walk through a couple of ways that we graph these things with the horizontal and vertical shift. One thing I'm going to ask that you guys remember to do, when you're doing your graphs, make sure you're labeling everything. A lot of you guys aren't doing that. Where's your vertex? Where's your focus? Where's your directrix? Axis of symmetry, and your symmetric twins. Yes, sir?
Do you mean label with coordinates too, or just the names?
Coordinates would be great, because that's what I do.
Okay.
All right? So let me show you an example. We're going to graph this and identify all of the parts. And for you guys, you're probably going to like this because it is very systematic. You follow a process. Like as we talked before, you guys are good at following processes. So we have the formula x minus 3 quantity squared equals 4 times the quantity y minus 2. That's the generic. What's p?
1.
Right.
Oh,
Okay, so this is how it's going to look, all right? What we want to do right away is identify if it's an x squared parabola or a y squared parabola. It's x squared. How do we know that? Because there's a squared around the x. So what I'm going to do is write out the generic formula. I know I'm going to work with that generic formula. From that, I can also take and figure out where my vertex is. What's my h and k? What's my h and k here? It's 3 and 2. Okay? So h and k So that is my vertex. So the first thing I'm going to do is plot my vertex. What's that? Correct. It's no longer at 0 because y minus 0 quantity squared is just y squared. X minus 0 is just x. We had an h and k yesterday, and we just called it 0. All right. Now, we do the same thing like you did yesterday. You identify what your p-value is. You take the coefficient in front of the parentheses of the y values, and you set it equal to? No. 4p. Same thing like yesterday. We take this value and set it equal to 4p. Just like you did yesterday. So 4p has to equal 4. What's your value for p? P is 1. Now, this is an x squared parabola. The value of p is equal to 1. So what direction is this going to go? It's going to go up. Everybody okay with that? All right. Yes. It's going to go up. So that means the distance from my vertex to my focus is 1. What's that ordered pair?
3.
3, 3. Very good. So my focus is at 3, 3. What's the value then for my directrix?
1, negative.
Ah,
3, negative 3,
3, 1, negative 3.
3, 1.
3, 1.
Negative 1.
what's the
No.
equation?
Y equals,
What is it?
Y equals 3.
Try
3,
again.
1.
Ladies and gentlemen, what is the equation for a directrix? Y equals or x equals. It is not an ordered pair. Directrix are lines. They're either x equals or y equals. This is a parabola that's opening up, so that means it's going to be a y equals 1. The reason that it's y equals 1 is because it's 1 below the vertex. The distance between the vertex to the focus is always going to be the same as the focus to the directrix, just in the other direction. All right? We know it's going to be opening upward. This is where it gets to be a little bit more lenient. It's very difficult to get sets of ordered pairs for symmetric twins when it's written in this format, because you have to get y by itself. It's a big pain in the butt. What we're looking at doing here is labeling everything. The only thing I haven't labeled yet is what? No, I just said you didn't have to worry. The axis of symmetry. Where's my axis of symmetry then? So my axis of symmetry, AOS, is x equals 3. One of the things that you guys tend to forget are equations for horizontal or vertical lines. Horizontal lines are always y equals some number. Vertical lines are always x equals some number. Please don't forget that. So when I ask you for the equation of a directrix, don't give me an ordered pair or I will start throwing things. Sure.
It's 3, 1.
Okay. Remember, what we're doing here, guys, is we're identifying which style this is going to look like, whether it's going to be x squared or y squared. We're identifying the center. We still find the p-value like you did yesterday, and everything else falls into place. All right? It's very similar to what you did yesterday.
So it's easy until I do this to you.
I'm not doing anything.
Yeah. Yes.
I have y squared equals negative. All right, can I say negative 1? Is it okay if I say negative 1? Equals negative 1 times.
Is this something different?
It's another. We're going to graph and write all this out again.
This is a different. Check.
Negative 1 times the quantity x minus 5. We're going to do the same scenario. We're going to identify our center, our p-value, our focus, our directrix, axis of symmetry, la-di-da, la-di-da. First thing, is this an x squared or a y squared parabola?
Y squared.
Y squared. So I'm going to write down the formula for a generic y squared. So it's y minus k, quantity squared equals 4p x minus h. Hopefully you guys were doing that yesterday with just the y squared equals 4px and working off of that. Now, from this information, I can take out my h and k. What's my h value?
5.
What's my k value?
0.
Good. So my vertex then is at 5 and 0. So I plot it. Now I got to figure out where this p value is. What do I have to set equal to 4p?
Negative
Good.
1.
I set negative 1 equal to 4p. So what's p?
Negative 1.
Good. So now we have a y-squared parabola with a p-value that's negative. What direction?
Down. I mean, left.
Left.
Guys, you guys start saying words.
You're trying to save yourself there. It goes down and then to the left, right? Yeah.
Words, guys. Get yourself.
Okay. So we know it's gonna look like this. All right. What's the equation, or excuse me, what is the ordered pair for my focus?
4 and 3/4.
0.
Good. So my focus, and this is, all right, I hate mixed numbers. They're a pain to work with. This is about the only time that I would say a mixed number kind of makes sense. Does everybody agree that 1/4 to the left of 4 is 3 3/4? What's a quarter less than $4? $3.75?
Yes.
Okay, you just kind of look at me like I'm like, you got like 17 different facial expressions and 7 heads going at the same time. Like I'm Medusa.
Where'd this 4 come from? I thought we were working with 5.
Hmm?
I thought we were working with 5. Where'd this?
Did I say 4?
Yeah.
I meant 5.
Okay. Okay.
So it should be 4. Yeah, I'm sorry. Yeah, it's 4 and 3/4.
Oh, okay.
I said, no wonder why you're looking at me like I'm on crack. Sorry. Now it makes sense. It all makes sense.
Not really, but you are recording now.
Of course. So the focus then is a quarter to the left of 5, which is 4 and 3/4. The directrix is at x equals what?
5 and 3. 5 and 1/4.
5 and a 4. Now, this is, like I said, this is about the only time that it makes any sense to use a mixed number, just because it's a little bit quicker to graph it out. There's no reason to switch them around. Later on, you'll see that we'll never use them again. You just said it. Where's the axis of symmetry?
0.
What's the equation for it?
Y equals 0.
Good. Know what you're going to say?
I was going to say, you can't have decimals.
I don't want decimals. I don't want decimals. Okay. So now I've got my focus, my directrix, my axis of symmetry, and everything's all good.
Can we find order pairs because it's on the 0 now?
You can if you want, but in the grand scheme of things, because you don't really need to with a lot of these, because it's okay. You're going to find out if you started messing around with these enough, which I know all of you guys just love to, with tons of these problems.
Quadratics make me get so excited.
Don't talk to me. The closer your absolute value is to 0 for your p-value, the wider the curve is. The greater your p-value, the narrower your curve is. So the closer your absolute value is to 0, you get a bigger curve. The bigger your absolute value is, the tighter it is. Yeah, this is a very wide one. Okay. Well, this is just the first step, just graphing. The second step is writing equations.
Oh, that's simple.
So we're the p-value. It's not something that's that big of a deal. Okay. But in case you were wondering, because I know you were. So let's take it to the next step. Let's write the equation of the parabola who has a vertex at -2 and 1 and a focus at -3 and 1. When we're given stuff like this, what you want to start out with is a rough sketch of what it looks like, because it's going to help you to identify what direction it's going. And once you identify what direction it's going, you're going to be able to know if it's an x squared or a y squared parabola. Do you agree?
Yeah.
It's very similar to what you guys did last night. Instead of being at the origin, you're at a different set of ordered pairs. So let's figure out -2 and 1. There's my vertex. My focus is at -3 and 1. What direction am I going? I'm going left. So if I'm moving to the left, is it x squared or y squared? Y squared. So let's write down the y squared formula. Good luck tonight. What are you swimming?
203 and 1.
I love the 200. That was my favorite. See ya.
Oh my God, wait, one. That was a good one.
Everybody okay with that?
Yes.
All right. We know our h and our k. Our vertex is given to us at -2 and 1. So there's h and there's k. We also can figure out the value of p by counting. 1. But I went to the left. So it's p. -1. So I know my p value is -1. Substitute it. Y minus 1, quantity squared, equals, what's 4 times -1? -4 with authority. And then it's x minus a -2, which I'm going to write as?
X plus 12.
You're done.
Can't we just like
Goodness.
multiply?
Told you it was that easy.
Multiply it out?
Nope, there's no multiplying out or anything like that. This is the standard form and you're done. Don't growl at me.
I don't like
No, because all you do is write the equations. All I ask you to do is write the equation. Notice, all we're doing here is getting a visual of where it's going, knowing what these mean, what direction they're moving, identifying the value of p, whether it's positive or negative, and substituting it.
Is that a trap?
What do you mean it's a trap? It's a trap.
Too easy.
It's not a trap.
I'm waiting for the cat.
No, I didn't see the negative part.
From just looking at that, vertex, focus, what direction does this open?
Down.
It's down. It's down like a frown, which means it's an x squared parabola. What's my h and k? 3 -2. So it's going to be x minus 3, quantity squared equals, and that'll be y plus 2. The p value. How far apart is the vertex and the focus? It's 2. So the distance is 2, but it's going downward. That means the directionality is negative. So your p value is? What's 4 times -2?
I did it right.
No, because wait, there's more.
No, see, I told you to simplify it more. You said I should simplify it.
I thought you were about to ask questions.
So what's a trap?
No. Now what do you do?
Simple solution.
Wait.
You everybody shut up. I'm factor.
Can't factor, my friends.
Yes, I will.
Move what?
You put y on one
Okay.
side.
Why you reverse this?
Alright, so you add the full y, and then you subtract the 5, and then you put parentheses on them, and you undistribute.
Okay. You're both on the right track.
Divide everything by 4.
Take a look at this, guys.
Solve the equation.
First thing I'm going to ask you, is this an x squared or a y squared parabola?
X squared.
And how could you tell it's an x squared parabola? Okay, never get that wrong.
Fucking guy.
How would you get it wrong?
Guys, I'm
Just
going
do
to
when you
do
make
quadratic
mistakes.
equation. Formula.
Everybody agrees that this is the generic form for a parabola. Right now, it's written in what's called quadratic form. I think it's written in quadratic form.
We have to know the form.
Now, at this point, some of you guys said, move the y's and the constant. You're right. Because here's what's going to happen. You're going to want to turn x squared plus 2x into a perfect squared. Which means you're going to complete the square. This is why we did this.
I'm doing quadratic formula checks.
What I've done here is I've set up completing the square scenario. I moved the 4y and I moved the 5. I added 4y and I subtract 5 to get it to the other side. I'm staying balanced this way. I'm going to complete the square. Remember, in order to do that, we take half of b, square it, add that to both sides. So we start out by taking half of 2, which is square it, you get. So I'm going to add 1 to both sides. Okay? What goes within your term then was the half of b. So what was half of 2 again?
1.
So it's going to be x plus 1 quantity squared equals 4y minus 4. I'm almost done. Nope, I don't complete this square on the other side because it's just, because at this point, what you want to do is notice what's in the parentheses on the right side. It's just y minus k, correct?
Yeah.
So that means the coefficient of y here has to come out. So what you do is you factor out whatever this number is in front of y. Sometimes it works out clean, sometimes it doesn't.
Like this one, that works.
This one works really nice. So now, where's your h and your k?
1 and negative. I mean,
That looks like
negative
an
1.
Negative 1 and 1.
Negative 1 and 1.
My h and k are at negative 1 and 1. Might as well. My h and k is at negative 1 and 1. It's x squared, so which direction is this going to go? Up. Plus we knew that because this value was positive. What's my p value?
1.
1. Very good.
How do you know?
Hey, Plano.
How do you know that? 4 times 1
Nada.
1. Yeah.
No, h and k are negative 1 and 1. It's x minus h. So that gives me my focus. My directrix then is at y equals 0. My axis of symmetry, is at x equals negative 1. Your focus here is at negative 1 and 2. What's that? Yeah, the focus is at negative 1 and 2. My vertex was at negative 1 and 1. So when you start to plot those things through, it works out rather cleanly. Yes, sir?
You should top the page so I can get some of your work. I was going my own way. I was trying to do the quadratic equation.
Don't
I got
do that.
negative 1.
I told you not to do it. You should just listen to me.
Agreed. I wanted to go my own way.
Do this one.
Okay.
Do that one, please. Yes, sir.
These aren't there.
How many trees do you have?
Are you okay? Can I go to a single screen?
Oh, no.
You didn't know it was there.
I just gotta copy it all down. I didn't notice it was there. I'm all good. I got my hand.
That's pretty big.
So you should start it out 8x, x squared plus 8x blank equals 8y minus 16.
Yeah.
Moving stuff around. Half of b, so we take half. 8 divided by 2 is 4. Half of that, or it's squared, we add that to both sides.
Yeah.
So the half of b term was 4, so it goes in parentheses as x plus 4.
Quantity squared.
Equals 8y.
See.
From that, you can get your h and your k. Your H value is -4.
Yep.
Your K value is
0.
0. So H K is -4 and 0. The coefficient of y in this case, since it's already out, there's no parentheses there, I set that equal to p, or excuse me, 4p. What's p? This is an x squared, so this is opening up or down, or up, down, left, or right? Up.
What?
We know it's opening up because p is positive, and it's an x squared.
But what is Paul?
Let's get a 2. What would be negative?
No, but it's somehow got my phone to the right of
I-
the vertex.
You flip-flopped H and K probably.
Oh,
What's that?
I made mistakes.
So, for the K, like I put one, I put 1, I know that's -1, but kind of minus the like, how, so zero, like,
So you're gonna have 8.
you know, like 8 parentheses Y, like, it's going to be, it won't be 6.
What happens when you, are you worried about up here? It just so happened that subtracting the 16 and adding 16 drops that out. It's still, remember how you used to always write in that -0? This is like the only time that it would make any sense at all. So the one time I said, don't ever do that again? Well, all right, so we know this is x squared. When I go to graph this, my vertex is at -4 and 0. My p-value is 2, so it means it's 2 above it. So that is at what? -4 and 2 is my focus. My directrix, that'll be at y equals, my axis of symmetry is at x equals -4. And it's going to be something like that. Okay?
Okay.
I don't know exactly, I'm not, like I said, when it comes down to figuring out sets of ordered pairs for these, it's kind of a moot point because it's really difficult to get y, well, this one isn't bad, but a lot of times it's difficult to get y by itself to use your table. So when you're getting in with a lot of these, it's just rewriting them into standard form. It's just going to be a rough sketch of the graph. When you get to the homework, it'll say graph. When you get where it says graph on these, you don't have to give me the symmetric twins. Just make sure you're getting directrix, focus, vertex, and axis of symmetry. Those are very, very straightforward, okay? Are you good with this?
Why is the word directrix so cool? Did you just say that parabola sounds like anything?
-2. This is a mixture of all three of those types that we just did. You'll be pleasantly surprised that they work out pretty clean. All right?
Okay, 628.
Yeah, I couldn't remember what page it was. I was at the board and I knew I had the problems in front of me, which ones I wanted to do on a notepad that I was working on, and then I just forgot to write down the page number. And I found it.
Very random.
Well, in this section, it's 10.6 is the section that has all the different shifted conics. So it's got parabolas, ellipses, circles, and hyperbolas. So we've got all of them to work with. So I just picked out just the parabolas.
Ellipses is an oval, right?
Probably is.
No, go ahead.
We'll probably start that tomorrow.
Here, check it.
Well, let me see.
I got this.
I'm gonna mail.
This is right.
You did it last year.
I'm probably getting that. This is right.
You worked the circles out. You did. You wrote the equation. Yes, sir.
Getting our test back.
Tomorrow, so the kids are about to get their, work done.
Yes.